Hello, good afternoon, my dear student. Today we will perform a new experiment, that is conversion of two-port network parameters. Okay, in a last lab class, you have experimentally measured the values of Z parameter for a combined network or cascade connection of two network. To one is resistive network, another one is reactive network. Okay, now you will verify the interrelationship between Z parameter and Y parameter for the same circuit. Okay, so let me share with you the link for today's experiment, the same link whatever you have used in last lab class. Okay, so now you use this link and visit to virtual lab site of IIT KGP. Okay, and then you proceed the same steps whatever you have followed in the last lab class. You you visit the virtual lab site, then you click on the simulator icon among the 6 icons, and then you can find out the link for today's experiment. You click that link and you see the circuit diagram. Okay, let me share with you the procedure for the today's experiment. Whatever these are same as the last class experiment. Okay, so you see these two type of network, resistive network and reactive network, because we will prefer the same network to verify the values of Z and Y, because in last lab class we have calculated the values of Z parameter for this composite network. So you must consider the same network in order to verify the relationship between Y parameter and Z parameter. So first what you will do to verify the relationship between Z parameter and Y parameter, you have already calculated the values of Z parameter. Now you calculate the values of Y parameter, Y11, Y12, Y21 and Y22. Okay, same in the same way. Okay, then you see the circuit diagram. Okay, this one circuit diagram. So you just select the MN network, composite or combined network, MN network. Okay, and then you select the parameters. Select the parameter. From parameter select option. You select Y parameter. You select Y parameter instead of Z parameter. Now you select Y parameter or short circuit admittance parameter. You have already covered the theory part of this topic. Then you select the input port. From port selection tab, you select the input port. Okay, and finally you click on the simulate tab, simulate button. Okay, you will get the values of input port parameter y11 and y21, y11 and y21. After that you select the port output port from port select option and you click on simulate button, and finally you will obtain the values of y12 and y22 parameter. Okay, and one thing you remember, that before going to execute the lab experiment, you must switch on your circuit power supply. You must switch on your power supply. Okay, if you face any difficulty to perform this experiment, or you have any doubt regarding the theory part of Y parameter or Z parameter, you write in your chat box. Okay, you write in your chat box about your confusion for today's experiment, or last experiment. Okay, about the today's experiment or last experiment, whatever we have completed. Okay, now let me share with you the values of y parameters. The values of y parameter, you see the values of y parameter I have given in the present slide. Okay, everyone first consider the same circuit whatever you have used in last lab experiment. Okay, I mean the combined circuit of or two-stage circuit of a pure resistive network and a reactive network. Okay, so how do you select this network? The composite network or combined network, you just click the tab Mn network. You see there are total 3 tabs available. One is M network, another one is N network, and third one is Mn network. So I suggest you must click on Mn network. Okay, then you will find out the combined network or two-stage network. Okay, which is nothing but a two-port network. Okay, consists of a pure resistive network and a pure reactive network. You know that resistive network contains only resistance element and reactive network consists of only energy storing element, maybe capacitor or inductor or both of them. Okay, then you say the values of y parameter, and you have already recorded the values of z parameter in last lab class. Everyone first calculate the values of y parameter, okay, and you write in your chat box after getting the result that you get the result. You just inform me about your result. Okay, so then I will proceed for the next step, that means conversion of two-port network parameter. How do we convert the z parameters to y parameter or y parameter to z parameter? Okay, we can calculate the values of y parameter from z parameter using theoretical concept. But before going to calculate the values of y parameter using z parameter values, you must measure the values of y parameter experimentally. You must measure the values of y parameter or short circuit admittance parameter experimentally, okay, using a combined network. You just tell me the values of y parameters y11, y12, y1, y22. However, in this slide you will see that values of y11 and y12 or y21 are 0 0, but this is not zero values. If you click on this button, then you will find out the non-zero value. It is 0.00 something. Okay, it is 0.00 something. Because the space is very small, okay, that's why it shows only 2 digit 0.00. But if you click on this button, on that particular button, then you will, or particular space, then you can find out the values of y parameters, non-zero values of y parameters. So first everyone complete the experiment. First you calculate, you measure the values of y parameters, okay, and you tell me the values of y parameter whatever you will get. Okay, whatever you will get. And if you have any doubt, any confusion regarding the experiment or theory part of this experiment, you ask me or you write in your chat box. Okay, I change the deadline of quiz from today to next week. Actually, CR request me that said we need some time for preparation. Okay, so that's why I changed the deadline of quiz. So I suggest all of you prepare yourself for the quiz. I will take the quiz later on. I mean next week. Okay, next week. I will change the deadline of the quiz. Okay. Now you tell me the values of y parameter y11, y12, y21, y22. These parameters are known as admittance parameter because this parameter signifies the ratio of current and voltage factor or voltage variable. And you know that the unit of this parameter is mho and unit of impedance parameter is ohm. So therefore, you first write the values of Z parameters and mention the unit as ohm, and you write the values of Y parameter and mention the unit mho. Or is it Acharya already got Y11 not, or is it Y11 not 0? You have used the same, have you used the same network? The values of resistance, capacitor and induction are same as the last experiment. Or you check the values of y11, y21, y12, y22. Okay, you just see the values of y11. I think this is not equal to 0. It will be a non-zero value, however very less value, but this is not exactly 0. This will be a 0.00 something. Arijit, please check the value of y11 parameter. Okay, y11 parameter, and then you verify. It is given 0.000. No, not 0.00. Other student, what about other student? What about other student? What are the values of this parameter? Write the values of y parameters. Other student, write the values of y parameter. Actually, I have a doubt particular for y11 parameter. This is not zero values. Origin, now you verify you just calculate the values of y parameter from z parameter. Z parameter values you know. In last lab class you have calculated. So now you calculate the values of y parameter theoretically from z parameter. Let me share with you the relationship between y and z parameter, which one I have derived in last theory class. You see, everyone say the relationship between y parameter and z parameter. Okay. Uh, in the present slide, I have given the relationship between y parameter and z parameter. You see that y11 equal to z22 divided by the determinant of that matrix, that is z11 z22 minus z12 z21. Okay, so y11 equal to z22 divided by the product of z11 and z22 minus the product of z12 and z21. You verify origin yourself. Y11 theoretically y11 equal to, let me write, z11 z22 divided by z11 z22, okay, minus the product of z12 and z21. Now you verify origin. Whatever values you have got in last experiment for impedance parameter, you put those values in this equation and you tell me what is the value of y11. If this is non-zero value, y1 is not equal to 0, then it is different. Okay, Arijit, no problem. You solve it yourself. What about other student? Write the values of y parameters and z parameters in your chat box. Let me check the values of y parameter and z parameters. Whatever you have got through this experiment. Same approach, same procedure. You must follow the same instruction. Okay. If you have any doubt, if any student has any doubt, any difficulty to perform this experiment, write in your chat box. Okay. How many students get the result? You see, this is a two-port network, and you know that to calculate the values of parameters. What is parameters? Parameters is nothing but the coefficient of independent variables. You know that there are total 4 variables associated with the network. Nivedita, you got. Nivedita, please write the values of your values of y parameter in your chat box. Let me check the values of y parameter, and later on you calculate the values of y parameter by using the values of z parameter, and you verify yourself the experimental result and the theoretical result. You compare the theoretical result and experimental result. If there is any mismatch between these two values, that means your experimental result is wrong or your theoretical result is wrong. They must be equal. The values of y11, whatever you have obtained through experiment, and whatever you have obtained based on theoretical concept must be same. If there is any difference between theoretical value and experimental value, that means there is something wrong either in calculation part or in experimental part. So you must recheck yourself and rectify the error. Okay. Two parameters. So there are total 4 variables: V1, V2, I1, I2. Two voltage and two are currents. Okay. If you consider two variables are independent among these 4 variables and remaining two are dependent, then you can originate theoretical 0.00318. Okay. So now you check the experimental value yourself. There is something wrong. Must be same. You calculate other values of y parameter, for example y21, y12 and y22, and you just compare the values, compare the theoretical values and experimental values. Both will be same. You check yourself. Other student, write your answer, or if you have any difficulty to execute this experiment, you write it in your chat box. Two independent variables we can consider and two are dependent variables. By using these two independent and two dependent variables, we make the equation, we make a relationship. Arijit, then there might be any bug in it. Now what to do? You just change the you just refresh the button and you repeat the experiment. You refresh your button, or you just you repeat this experiment, or you can change the values of y parameters, sorry, values of resistive and resistance and inductance capacitance. For other set of z parameter you can check, or other set of external elements of y resistance, inductance, capacitance. You can verify the values of y11, y12, y21, y22 parameters. Okay. Or you can change the network also. Instead of n network, you can use n network only. whatever, you just verify yourself either using the single stage network or this double stage network, and you uh, consider the values of elements for two questions. Theoretically 0.000317 Nivedita got. And what is the experimental value, Nivedita? Experimental value of y11. If these two are different, then you refresh the link and you repeat the experiment, or you can consider other set of z parameter values. Other set of z parameter. Actually, I got this thing 0.00317 experimentally. Same values. And after refreshing also it is coming 0. Okay, Arijit. Then Arijit, you do one thing. You just consider other set of means other set of external values of external element, R1, R1, R2, R3, and L1, C, etc. You just consider the other set of Z values, and you calculate the Y parameter values for other set of Z values. I mean, you change the elements, change the values of elements for the for your circuit. Actually, I got the same value. Experimental and theoretical value both are same. I got. I don't know what is the problem associated with your circuit. Maybe there is some bug. Anyway, you just consider other set and you check it. You repeat the experiment for other set of Z parameter values, and you must consider corresponding circuit elements, corresponding values of circuit elements, resistance, capacitance, and inductance. Okay, so if you just check it yourself, other student write the answer, write the result of your experiment, and let me check your result. How many students got the values of y parameters? You write in your chat box. You say to calculate the inverse of a matrix, you must need to calculate the values of the calculate adjoint of the matrix and also determinant of the matrix. After getting the values of adjoint and determinant, you just take ratio of these two values. He considered adjoint values as with other set of values also it is coming 0. Okay. Uh, then Arijit, you you can repeat this experiment later on. Okay, after some time. Okay, and that time you see what is the value of y1. If you get, you will get the y1 value is equal to 0. Then you just write in your lab record that you got 0 value, and you just write in actually conclusion part that there is something wrong with your circuit because this is software based experiment. Maybe there is some a bug or actually a programming error, that's why. Okay, it comes now. You just repeat this experiment after some time. If you get the same result, then you just write in your conclusion or inference part that because of programming error you got this result. Okay, so in your lab record you must mention the reason why you got the different value. The experimental value is different from the theoretical value. You just mention, everyone mention, and you can repeat this experiment after some time. Okay, Now you calculate the values of each parameter and ABCD parameter. You actually you have calculated y parameter, and you verify. Now you calculate the values of each parameter, ABCD parameter, and you just check their value also, theoretical value and experimental value. Check it yourself. You just use the relation between z parameters and h parameter, z parameter and ABCD parameter. Okay, you just use the theoretical, you just use the relationship. First you consider the relationship, and then you put the values of individual z parameters, and you check yourself for each parameter case. Age 1 age 1 to age 2 age 2 to. First, everyone calculate the values of hybrid parameters experimentally. How do you calculate the values of each parameter experimentally? You just change the parameters. You just change the parameter y. You choose h from the parameter selection part. And same way, input port, output port, you click simulate, you will get the values of h11, h12, h21, h22. Then you consider their relationship. Consider the relationship between z parameters and h parameter. And you put the values of z parameter and you check the theoretical values. Okay. And finally, you compare theoretical values and experimental values for h parameter case also. Okay. However, you got the different values for y11. Particular y11 values is different. Other parameters are same na for experimental and theoretical case. Origin Nivedita, y12, y21, y22 are same for both case, experimental and theoretical. If you got the same values, then you proceed for the next case, that is h parameter case. H parameter case. Okay. Who have got the values of y parameters, z parameters, and theoretical value, experimental values are same for other parameter y12, y21, y22. Then you proceed for the next case, age origin age11, age12, age21. Okay, origin. Now you use the relationship between z and h parameter, and you just use the values of z parameters, and you check h parameter for theoretical case. Okay. Okay, and you compare it yourself, and you share your result after comparing theoretical values and experimental values. uh, or if you check other values of y, then it will be clear for us that both cases are same or not. Then we can conclude. If all are different, then we need to repeat this experiment. You check other values of y parameter, y22, y12, y21, y22, y12, etc. Okay, everyone must complete this experiment. Okay, must complete this experiment, and you verify the theoretical result. You compare the theoretical result and experimental result. Both cases you will get the same values. If you get different values, that means there is something wrong with your calculation part or experimental part. You just rectify it yourself. So can you please provide the formulas? Formula for y11. Why you see? Okay, let me. You just see the present slide. I have provided the formula. Y12 equal to y12 equal to, you just see. You can write yourself if you see the present slide. Y12 equal to minus z12 divided by z11 z22 minus Z12 Z21. Okay, Arijit, you see the present slide and you compare, then you will get, you can obtain yourself the relationship between y parameter and z parameter. Y12 equal to minus z12 divided by z11 z22 minus z12 z21, and y21 equal to minus z21 divided by z11 z22 minus z12 into z21 z21, and final is y22 equal to z11 divided by z11 z product of z11 z22 minus z12 z21. This is determinant. Okay, now you calculate the values of y12 y21 y22 by using the values of z parameters. I have given the relationship, okay, between these two parameters. You complete this experiment conversion. Actually, I told you in theory class that what is the importance of this conversion. Why do we need this conversion approach? We can calculate the values of z parameter, y parameter, h parameter, transmission parameter from the circuit directly. Then why, what is the reason behind it? Conversion approach. Why do we need conversion approach? Can anyone tell me what is the merit? What is the merit of this conversion technique or conversion approach? Can anyone tell me? In theory class, I have shown you the steps required for calculating the values of z parameter, y parameter, h parameter and transmission parameter for a two-port network. We can calculate it directly from the two-port network by considering it input voltage, output voltage, input current, output means port 1 uh, current, port 2 current, port 1 voltage and port 2 voltage. Then why do we need to use such conversion technique? The merit of this conversion technique is that without rigorous calculation or complex mathematical calculation, we can easily determine the values of each parameter and transmission parameter from z parameter and y parameter. You know that it is easier for us to calculate z parameter values and y parameter values compared to h and ABCD, because you know that this y parameter, each parameter hybrid parameter, we need to consider both port current and voltage, and ABCD also we need to consider the output port current is leaving from the network. I have calculated the value y is somewhat different. Practically it is at and theoretically. Okay, it is okay. Origin 0.00384 to 0.030. It is near about same. It is okay. This difference is okay. No problem. We can say theoretical value and experimental value same. Okay. This is okay. Correct. This is correct. Y12 is correct. Arjit, you are correct. Other student, write your result in your chat box. Okay, let me check your result. If any error, or then I can explain it. I can tell you. Okay, Arjit, thank you. Then you compare other two case y21 and y12 you got y21 and y22, and then you proceed for the next uh, case, h parameter case. Uh, Other student, write your result. What about others? Other student, silent as usual. Other students are silent as usual. Write your answer. Write your result. Okay. And you know that a symmetrical network must satisfy the condition Z11 equal to Z22. Symmetrical network. For symmetrical network, input port impedance equal to output port impedance. Z11 equal to Z22. Everyone must complete this experiment and you tell me about your doubt. Okay? About your doubt. I am getting the theoretical value 0.003. Okay, Nivedita, it's correct. Okay, no problem. It is near about same, both cases. Okay. Arijit got, Nivedita got. Other student, write your result. Arijit y21 and practically y 0.0030. Okay, Arijit, y21 is also correct. Is also correct. And for y12, we got y21 is also correct. Y12 is correct. Y21 is also correct. Okay, Arijit, correct. That means only y11 parameters. Y11 parameter. Everyone complete this experiment and you verify the theoretical result and practical result for y parameters. In your lab record, you must mention the theoretical values and practical values for y parameters. Okay, so let me tell you the steps which are required to write the lab record. First, you write the name of this experiment. The name of this experiment is conversion of Z parameter to Y parameter. Okay, and you must mention the number of experiment number. You must write the experiment number 8, date, today's date. Then you proceed same. Okay, Arijit, thank you. Uh, then you mention this the values of y parameter in your lab record, no problem, because you got the same values for all three cases. You just check yourself later for y11 case. If you get different value, no problem. You mention in your lab record. You just give a reason regarding this. Okay, then everyone uh, write the required elements for this experiment, then theory part in brief, then methodology or procedure including diagram, circuit diagram. In result section you must mention the values of resistance, inductance, capacitance, and you use a table for y parameter values. Finally, you write the theoretical values and experimental values. You must mention the theoretical relationship. You must mention the relationship between y and z parameter and theoretical calculation. And finally, you write the conclusion or inference for this experiment. Okay. Uh, Thank you, everyone. I hope everyone understood this experiment and got the result. If anyone has any doubt, you can ask me. Okay. Thank you, everyone. If you have any queries regarding the other experiment, whatever we have done so far, you can ask me. RLC circuit, RC circuit, maximum power transfer theorem, superposition theorem, resistive network, two-port network. If you have any doubt or any queries regarding any experiment, we have already completed 8 experiments. So if you have any query, you can ask me. You write in your chat box, because in next week, next to next, your term will come. Next to next week, I will ask you question in quiz session. So you prepare yourself. Thank you, everyone. Okay, let me stop here today's lecture. Everyone must submit the lab report within the deadline, on deadline or before deadline. Don't take much time and submit it after deadline. Late submission means some or few marks will be reduced. So you try to submit your lab record before the deadline or on deadline. Thank you.